All right, here's a little trick to find out if your fuse is good in your multimeter. This is one of the multimeters that I use on a regular basis, the Fluke 117. This is one of two that I carry here at work. I also use my TX3, and I started to use the Klein. Oh, this isn't it. The Klein MM720, just for the fun of it. I got it at a pawn shop for 25 bucks. I think it's new, like $99. But when you're out there using your multimeter for gate operators and access control, you will come across running current through the multimeter as opposed to voltage, where you're checking between 2 points the potential of something. We're actually going to run the current through the multimeter, and that's where a heavy duty high rupture capacity fuse comes in handy. Now this one is actually only for 440 milliamps, so you'll find some meters that come both ways. It'll have a 440 and it'll have a 10 amp. Like this one has a 10 amp fuse in there. But some of them will have 440 and 10 amp. And generally, it's denoted by having an extra BNC connector. It's not a BNC connector, some other connector. Banana connector is what I'm going to call it for now. But and actually, if you don't know that, the banana connectors, the same ones that you use for speakers, can actually fit in there. I've got a video out there showing you how to make those. But going back to the fuse, every once in a while you'll blow it up. We're testing solar panels most of the time with the fuse, and we're not pulling any more than a couple of amps, but sometimes you will blow the fuse if you have your meters in the wrong spot, or if you have your probes in the wrong spot, or something along those lines. You could actually damage it. But before you actually use the current part of your multimeter, you need to make sure your fuse is good. And the easiest way to do that is to use your multimeter to test it out. Now, you can put it in resistance. You have your multimeter and resistance plug, voltage plug, continuity plug, and various other features that it does. And then you can plug it directly through the amp setting or the fuse that is connected to the amp setting. This has an ammeter built into it, and that's generally what we're using when we're testing short circuit current through the for a solar panel and through the meter. And because this fuse has some resistance in it, in this case it looks like 100 milliohms, it will show up on your meter. Now the other thing about that is just because it may show higher resistance, so just because it shows 0.1 or 5 or 6 or 1,000 ohms doesn't necessarily mean that it's bad. You have to go to your manufacturer manual and see what it's at. Now, if you don't have that, the best thing to go by is that it's not showing OL, which is out of range, overload, depending upon the manufacturer, how they label that. You'll see something like, let's see if I can find a setting that has it on there. God dang it, I can't even think of a setting that would have it on there. Okay, anyways, you'll see OL and whatever it is, 8-digit display or 7-digit display. And with that, you will know that most likely, not most likely, there is an open, whether you have damaged leads or whether you have a bad fuse. That will be something that you have to determine, because you don't want to always take your meter's word for it, because you could have something plugged in wrong, or you could have a bad probe or a bad lead or a bad connection, and it doesn't have anything to do with the fuse. It just has to do with something else. So that's how you test a fuse in your multimeter without taking it out and then using another multimeter or this multimeter to test continuity through it. It's the easiest way to do it.